Now, it might seem like all the focus has been on JWST lately, whereas the Hubble Space Telescope, or HST, has been left to rot by the wayside, but that couldn't be further from the truth. HST is the most productive telescope we've ever had, being useful to just about every single field in astronomy, from solar system to stellar formation to galaxies both near and far. And that science is not slowing down anytime soon, because the oversubscription rate, so the total amount of time that astronomers propose to use Hubble to do their science, within the span of a year, compared to physically the amount of time available on the Hubble Space Telescope in a single year, is 7.4 to 1. So the demand from astronomers is still literally sky high. So it probably comes as no surprise to hear that NASA recently extended Hubble's science mission until 2026. That's all well and good that us astronomers still want to use Hubble to do our science, but there's also a bit of a ticking time bomb when it comes to the Hubble Space Telescope, and that is its orbit around the Earth, which is slowly degrading over time. It's dropping in altitude, making its orbit sort of trace this long extended spiral until one day Hubble will fall.
He fell.
Hubble is in what's known as a low Earth orbit, with an altitude on average at the minute of around about 535 kilometers. That puts it in what's known as the thermosphere, a layer of the Earth's atmosphere which is incredibly underdense. It's practically a vacuum in terms of the number of particles that you have in a given volume, but that does increase whenever you have a solar storm. So when the sun burps up these high energy particles that cause the beautiful aurora or northern lights here on Earth. But it's not all beautiful light shows, because those particles can also impact with spacecraft like the International Space Station or the Hubble Space Telescope in its low Earth orbit, and essentially cause a drag force as they hit into the spacecraft, causing it to drop in altitude. So it really does depend on how active the sun is going to be in the next couple of years as we're actually approaching solar maximum in terms of how long the Hubble Space Telescope has left before its orbit spirals it back down to Earth. The best estimates put it at around about the mid-2030s. Now, it was never NASA and ESA's plan to let the Hubble Space Telescope burn up through the atmosphere, not least because they want to bring it back down safely and put it in a museum like the Smithsonian, to preserve it as part of human history. But also because the mirror on board the telescope is 2.4 meters wide. That's very unlikely to actually burn up completely in the atmosphere, and so if that were to hit a very densely populated area, it could cause a serious amount of damage. The original plan when it was launched back in 1990 was to bring the Hubble Space Telescope back to Earth with the Space Shuttle when it reached the end of its mission. And up until that time, the Space Shuttle was also used to give the Hubble Space Telescope boosts in its orbit to combat that atmospheric drag that was causing that orbital decay. Of course, the Space Shuttle was retired in 2011. The Hubble Space Telescope outlived the Space Shuttle. Its last visit from a space shuttle was the final flight of Atlantis in 2009 as part of STS-125. During that mission, they fitted 2 new instruments on board the telescope, so things that actually record the light, one of which I've since used in my own research on how supermassive black holes grow in galaxies that have been left alone. And they replaced all 6 gyroscopes on board the Hubble Space Telescope, which allow it to know whether it's pointing in the right direction and at the right object. People often think that it's fuel that we use to point the Hubble Space Telescope. You sort of burn it in one direction and that'll push it in the other direction. But actually that would be completely unstable and wouldn't allow you to point as accurately as you need to. So instead, the Hubble Space Telescope has got solar panels, which it uses to generate electricity, and then uses that power to tip and tilt the spinning reaction wheels on board in the opposite direction it needs to go. The gyroscopes can then be used to track and maintain that position of the telescope pointed and fixed at a certain object, essentially by pushing back on the rotation of the telescope. This is also similar to how JWST points at certain objects. However, JWST's mission lifetime is limited by the amount of fuel it has because it needs fuel to keep it in orbit around Lagrange point 2. And when that runs out, it's very likely that it's going to have a very fiery death in the sun. But back to HST's gyroscopes, because 3 of the 6 that were installed back in 2009 were of an older design, one that was tried and tested. We knew it worked, but we also knew that they had a much shorter lifetime. Those have since failed. They're no longer working anymore. The other 3 were of a newer design that wasn't so tried and tested yet. Thankfully, those are still going and keeping the telescope going as well, albeit with a little bit of jiggling and shaking of the telescope and some turning them on and turning them back off again. But when they failed in 2018.
Hello, IT. Have you tried turning it off and on again?
But it could be that those fail in the next couple of years before we even have to worry about HST's orbit decaying and bringing it back down to Earth and that ending the science mission early. But assuming they do continue to work, and assuming that we still want to continue doing science with the Hubble Space Telescope, especially in parallel with JWST while we have that up there as part of its 15-20-year mission, so that we can cover a much more useful and productive wavelength range, running from the ultraviolet and the optical and into the infrared, then we need a way to give the telescope a boost in altitude to combat this orbital decay. Now, back on STS-125, that last space shuttle service mission of the Hubble Space Telescope, the astronauts installed what is essentially a fail-safe device called the soft capture mechanism, which is a ring-like shape attached to Hubble's aft bulkhead, which could allow for the safe capture of the Hubble Space Telescope by any spacecraft. It's like a universal docking system, just giving other spacecraft something to grab onto without damaging the telescope itself. But herein lies the problem, because NASA don't currently have any spacecraft that they could use to do that thanks to the commercialization of the space industry. So, in September 2022, NASA signed an agreement with SpaceX to complete a study about whether it would be possible for SpaceX's Dragon spacecraft to dock with the Hubble Space Telescope and move it to a higher orbit. Now, Dragon has successfully taken both cargo and crews of astronauts to the International Space Station, so it's a tried and tested spacecraft. There just needs to be a feasibility study first, analysing data on the flights of the Dragon spacecraft and also of the Hubble Space Telescope's orbit. Plus, in December 2022, NASA put out a request for information, essentially asking for other space exploration companies to conduct a feasibility study of their own for docking with and boosting the orbit of the Hubble Space Telescope. Question is, can they do it? It sounds simple enough to me, she says, as an astrophysicist and not an engineer. So we're just going to have to wait for the outcome of these feasibility studies so that us astronomers have some idea on how long we can expect the Hubble Space Telescope to be around for. Because ideally we'd like to have it for as long as possible, because the next generation of ultraviolet and optical space telescopes we're going to be waiting a while for. Like the Nancy Grace Roman telescope, which covers from blue light to the infrared. That isn't set to launch until 2026, 2027. Let's be honest, these things always get pushed back a little bit. And then you've also got LUVOIR as well, which will cover the ultraviolet, the optical, and just a little bit into the infrared. That's not set to launch until 2039. I feel like setting the launch date of 2039 is like the retail equivalent of setting the price of something of $9.99. Like, it's not £10, it's £9.99, right? We all know it's probably going to be more like the 2040s and not 2039 that thing launches. So if we want to make sure that that wavelength gap of ultraviolet to the optical has some coverage with space telescopes, especially during JWST's lifetime, then we're going to need a commercial space company to help save the Hubble Space Telescope. So as much as us astronomers really don't like SpaceX and all these other companies that are launching these big satellite constellations at the minute for all the damage they're doing to ground-based observatories, turns out we might just need them to save our favourite toy of astronomers, the Hubble Space Telescope. propose for to use Hubble to do their science compared to the physical increase whenever there's a solar storm. Piece of fluff. Ha 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 ha. Reactions of, I don't know. What is it when you have really good reactions? Like, oh, another one. Oh, I missed it that time. Okay, my reactions aren't actually that good. Anyway, it could cause some serious damage if it were to hit an inhabited area. Inhabited? A habited area. You inhabit it. Inhabited, yes. Populated areas, let's just say that.